using the t equals 0 plus diagram, find our x prime of 0 plus. So I got a little ahead of myself with step 2. I said we'd find that too. I'm going to keep that for step 3, just because otherwise this video is going to be way too long. So using the t equals 0 plus diagram, find x prime of 0 plus. And remember, the way to do that is to go from this non-primed world into the primed world. We're always going to use the constitutive relationships for the capacitor and the inductor. And those constitutive relationships is IC equals C dV dt, and VL equals L di dl. So these are always relationships. If we know what IC is and VL is, we can figure that out from over here. So it's easy to then, if we're asked to find VC prime and I sub L prime, it's easy to find out what those are. If you're asked anything other than VC or IL, then you're going to have to get creative with using first these relationships to find VC prime and IL prime, and then using other relationships to find the rest. So those other relationships are things like Ohm's law. So the voltage across the resistor is equal to the current through that resistor times that resistor value. And if that's true, you can take the derivative of both sides of that equation. The R is constant. Or, so this is Ohm's law. Or you can use KVL. The sum of the voltage drops around a loop is equal to 0. So therefore, if we take the derivative of it, that must also be true. The derivative of 0 is 0. And similarly, we can use KCL to say that the sum of all the currents exiting a node has got to be 0. So therefore, we should be able to take the derivatives of I1 and I2, and that must also be 0. So these are our maybe rules on the right. Use them if you need them. Let's begin. Let's start off with VC prime. So to find VC prime, we're going to use this first equation. That's where VC prime exists, and it's a function of IC, which is not prime, so it's easy to figure out. VC prime is equal to 1 over C times IC. And although we didn't figure out IC already up here, we can look down into our circuit at t equals 0 plus and figure it out. We've defined VC in this way with a plus on top. And VC, remember, it's a capacitor, so we have to use passive sign convention. So we've got no choice but to define our IC in that way. And because that's true, we can now try to figure out what our IC is. Once we do that, we can plug it in here and solve for our VC prime. So how do we figure out what IC is? It's not anything, it's not directly a function of 6 amps, since that 6 amps can be shared around a bunch of different things. It can be shared between this, and it can be shared through this leg and this leg. For the same reason, it's not something simple with 12. Let's see if there's some other way we can figure out what that IC is. We never figured out what IC is up here, but we do know what IL is, right? We figured that out already. It's 6 amps. And one other current that we know is the current through this 4 ohm system, because if we call the bottom, say, ground down here, then this is 12 volts and this is 24 volts. And that means that there must be 12 volts across here divided by 4 ohms means there's 3 amps flowing in that direction. There's 12 volts different divided by 4 gives us 3 amps. And I wrote that down because now we're in a position to do a KCL up here. And our KCL says that our current flowing to the left out of the node is 3 amps. Our current flowing down here, we don't know what that is. That's what we want to find, is IC. The current flowing down to the next leg is 6, and the current flowing down to the final leg is negative 12. And all that has to equal 0. And so therefore, IC must equal 3 amps, right? Because 3 plus 3 plus 6 minus 12 is 0. And now we can figure out what VC prime is. It's 1 over C, which is 5, because C is 1/5. So 1 over 5 is 5 times 3. And all that is 15 volts. But it's not volts, it's prime, so it's volts per second. And that's the first thing we're asked to find. Primed. Didn't give myself enough room. 15 volts per second. Next one. Now, of course, if the problem asked you to find VC, all you would really do again is just find those two things, and then you'd stop there. But for this example, we'll find them all. The next thing we want to find here is I sub L prime. So we know that we're going to use, we see the I sub L prime here, so that's pretty straightforward. It's equal to 1 over L V sub L. Did we already find what V sub L is? Yes, we did. Over here, we know what V sub L is at 0 plus. So that's going to be equal to 1/7 times 0, which means it must be 0 amps per second. So that will be 0 amps per second. Okay, so next we want to find what our V sub 2 prime is. Now, unfortunately, there's no V sub 2 in here, so we're going to have to use what we already found out in terms of primes, plus these guys. And let's fool around with this idea and see what we can figure out. I want to find this V sub 2, and the first thing that strikes me is that there is this loop around here. By the way, I'm going to lead you down a false road, but it's okay to take a couple of false roads while we're understanding. I can do a loop around here, and I can say, summing up the voltage drops around this loop, starting from our V sub L, gives us plus V sub L plus V sub 2 minus V sub C equals 0. And the reason why I'm looking at this particular thing is I'm trying to find some equation that involves V sub 2, because my next step is going to take the derivative of this. So V sub L prime plus V sub 2 prime minus V sub C prime is equal to 0. And now I could solve for my V sub 2. And it's going to be equal to V sub C prime minus V sub L prime. So I ask myself, do I know what V sub C prime is? And I say, sure, it's equal to 15 volts per second. Do I know what my V sub L prime is? No, that's one of the things I need to find. So it's a good idea, it's a good approach, but it doesn't work. It's not wrong. It just simply won't let us find what we want to find because we don't know what V sub L prime is. So let's find out some other relationship. So looking back on this, what do I see? I see all these voltages, but that's not going to help us. I want to find V sub 2 prime. I guess I could sum up all the voltages through this loop. That would give me plus VL plus V2 plus whatever this voltage is, but I don't know what that is. So that's not a good way. Maybe I could do it through this loop. That would give me minus V2 minus VL. Once again, I'm stuck with this VL, and that's not going to help me. How about using Ohm's law? So I know, for instance, that the voltage V2 is equal to whatever that resistance is times the current going through it, which is I sub L. And if this is true, I can take the derivative. So far, our first attempt was this rule. Our second attempt is this rule. Do we know what I sub L prime is? Yes, we do. It's 0. So it's equal to 4 times 0. And so that's going to be 0 volts per second. And that is our answer to this, volts per second. Let's finish up with the last question, which is what is V sub L prime? So once again, we go to our original two equations. Unfortunately, V sub L prime isn't there, so we're going to have to somehow pull it out of this. One way to do that is using the equation we already tried. Remember, we already tried going around this loop. So let's go around that loop again. When we first went around that loop, just doing a regular old KVL, we got V sub L plus V sub 2 minus V sub C equals 0. And therefore, we can take the derivatives of everything. The derivative of 0 is 0. And now we can solve for our V sub L. It's equal to V sub C prime minus V sub 2 prime. And last time we weren't able to go any farther, but now we know what VC prime is. It's equal to 15. We know what V2 prime is. We just figured it out at 0. And so this is going to be 15 volts per second. And now we found everything we were asked to find.